So we're going to do a little demonstration here to show the concept of equilibrium. I have some blue water and an empty beaker. This is going to be our reactants. This will be our products. What we're going to demonstrate is the concept of equilibrium. What we're trying to say is that equilibrium does not always mean what you think it means. So here we go. I have two beakers. We're going to pour from one beaker into the other by filling them completely full and dumping. We're just going to do this for a while. What I'd like you to do is, on the video, just think about when you think we're at equilibrium. Are we there? What are you noticing? At this point, you might notice that the amount of water in the two big beakers is not equal, but the volume doesn't seem to be changing as I'm going back and forth between them. What's happened is we have become at equilibrium. Equilibrium does not mean equal. Equilibrium is a state of a reaction where the forward reaction is taking place at the same rate as the reverse reaction. If we were to pause here for a minute and I were to go get two graduated cylinders, and of course they don't have the right size, we will see that these are very, very close to being the same volume. In the big beaker, it should be pretty close to 150 milliliters. And in the second one, it should be pretty close to 150 milliliters. Now these two graduated cylinders are theoretically the same size, and you'll see that it's not exactly the same, but they are very, very close. If I were to keep doing this a couple more times, we'll put that water back into their respective beakers. If I were to do this a couple more times, I should be able to get to the point where I have the same volume in both beakers at the same time. So let's try it couple more times here. That looks pretty good. Well, let's go one more. There and here. All right, let's see what we got. So again, this should be pretty close to 150. And that one is 148. And over here, we have 148. Look at that. I told you I could do it, didn't I? Those two volumes, I don't know if you can tell on the camera from the angle it's at, they are exactly the same. The amount of water that was contained in both beakers was the same. Even though this beaker is a larger beaker, it was not being filled to capacity. The small beaker was. It was completely full. So as we started to pour back and forth, the rate of the forward reaction, the water going from the reactants into the products, was the same as the reactants going to the products going to the reactants. Both directions of the reaction were taking place at the same time. What that would look like is, in definition, I just gave it to you, it's the equal rates forward and reverse. So the rate of forward reaction is equal to the rate of the reverse reaction. Okay? What we would say here is our reactants are becoming products, but at the same time our products are becoming reactants. And we have this new symbol, two-sided arrows. Previously in chemistry, we had always talked about how a reaction proceeds to products, and we wrote a one-directional arrow. From here out, we are going to be using two-directional arrows to talk about an equilibrium reaction. Most reactions in nature take place as an equilibrium, not as a straight reaction. Now there are some that we can think of that aren't reversible. You can't turn water back into hydrogen and oxygen very easily. It doesn't mean we can't, but when I take hydrogen and I go kaboom and light it on fire, it is one of these reactions. In order to make it reverse, requires a lot of energy. In order to change the burning of any fuel, combustion reactions tend to not be very reversible. You can't take a piece of wood and reverse that reaction and turn carbon dioxide and water back into wood. However, if you remember from your biology, that is exactly what takes place in photosynthesis. We have carbon dioxide and water arranging itself to form sugars and oxygen. You guys remember that? So the sugar and oxygen would be the fuel going to form carbon dioxide and water. If I take carbon dioxide and water, that's what allows plants to grow. I hope this was helpful. There will be more notes from a different source in just a few minutes.